Right, this is Edexcel June 24 paper of Further Maths Core Pure 2 paper, and it's question 2. And by the looks of it, well, yes, I can see, it's a MaClaurin series question. But it uses hyperbolic, inverse hyperbolic. It uses tanh, or R-tanh here. And we start off by saying that f of x is tanh to minus 1 of 3 minus x over 6 plus x. I say tanh or than. Lots of people say different things. It really doesn't matter that much. Anyway, and we need to show that the first differential of this, f dash x, is minus 1 over 2x plus 3. So many ways we could go about this. Firstly, never forget, lots of help in here in your formula booklet. And it actually gives you the differential of R tanh. It tells you that if you differentiate R tanh, which obviously tanh to minus 1 is R tanh, you differentiate that, you get 1 over 1 minus x squared. See, I have to remind myself of what it is. So, to be honest, the most simplest way of doing this is really using a chain rule, calling this u and differentiate from that, I would say would be the most obvious way. Other ways, if you really wanted to, I'm going to rub these out, but I suppose you could start off with y equals tanh to minus 1 of 3 minus x over 6 plus x. And then that means that tanh y is 3 minus x over 6 plus x. Yeah? Of our tangent in there, and then implicitly differentiate. I think it's sec squared there, dy by dx. That differentiated, you could then change the sec squared into sec squared y into tanh y using a hyperbolic identity, and it could all come out from there. That wouldn't be too bad, I think. I think really, I mean, you've got that in your formula booklet, just use that. I think it's going to be the easiest way to go. So let's start off. Let's do it nice and formally, shall we? We can start off by going that f of x is tanh to the minus 1 of u, where u equals 3 minus x over 6 plus x. So we know if we differentiate that, we can just get that straight out of the formula booklet, but we then got to times it by du by dx. Okay, simple little bit of chain rule. So we're going to have to work out what du by dx is, so let's differentiate that. Should have quotient rule. So u and v, you know what, I can never remember the u dv, anyway. So let's do u dash, actually, it's quite confusing, isn't it here, using u then u there. Never mind, I'm sure we can work this out. So that's going to be u dash is going to be minus 1, and v dash is going to be just 1. So it's going to be, dearie me. I'm going to look this up because otherwise I forget it every time which way round it is. uv times so it's the u dash v. So minus 1 times 6 plus x, so minus 6 plus x. Subtract v dash times u, so subtract 3 minus x. That's right, isn't it? It's f dash x g of x minus f of x g of dash x. Yeah, I'm so slow on this. I remember it's over v squared. So that becomes, what's that? Minus 9 minus x plus, that's it, minus 9 over 6 plus x squared. He says, let's hope I've done that correctly. Minus 6 minus 3 minus 9, and minus x minus x, yes. Ooh, that's nice. Okay, so let's plug everything in. So it's 1 over 1 minus u squared, which is, u is that. So it's 3 minus x over 6 plus x squared. Let's put them both squared. And we're timesing that by minus 9 over 6 plus x squared. Oh, because of the 6x plus x squared there and the 6x plus x squared there, isn't it nice to just times them straight in? And we're going to get minus 9 on the top. And that times that will give us a 6 plus x squared here. Minus 3 minus x squared here. I'm sure some of you are shouting at me saying, why didn't you just do this? But I'm committed to this now, I'm going with it. 6 plus x all squared, what's that? 36 plus 12x plus x squared. Minus, right, let's put it in a bracket to start with, shall we? Just to make sure we don't make any messes up. 9 minus 6x plus x squared. Sort that out, minus 9 over, right, 36 minus 9, so 27, lovely. And then 12x minus 6x is 18x. And then x squared minus x squared, oh, lovely, it's gone. So that just cancels 2, divide by 9, we get minus 1 over 3 plus 6x. Oh, divide by 9 and gives 6, dearie me. 2x, dear me. Yep, that's what we want. And you know what, I'm just going to write this, even though I'm sure they wouldn't penalise us at all. I've seen some ridiculous things sometimes. So, it's done, we proved it, done. Okay, right, part B, we hence have to determine the second differential, f dash double dash of x. So let's just leave that up there for a second. And it's only a 1 marker, so that should tell us it should be pretty straightforward. It is. So if f dash x is that, let's write it as minus 2x plus 3 to the minus 1. So f double dash x minus 1 comes down the front, so that turns it into positive. 2x plus 3 differentiated is 2, so it's going to be 2x plus 3 to the minus 2. Take 1 off the power, that comes down there, times by that differentiated, done. So it's what, 2 over 2x plus 3 squared. Nice and easy, simple mark. Hence show that the MaClaurin series for f of x up to and including the term in x squared is ln p plus qx plus rx squared, where p, q and r are constants to be determined. Okay, right, so again, MaClaurin series, if you forget about it, is in your formula booklet, so you can just look that up. You don't have to commit that to memory. It should be nice and centre there. But we need to evaluate f of naught, f dash of naught, f double dash naught. So f of naught is tangent to minus 1 of putting naught in there, a half. And again, in your formula booklet is your r tang, which is a half ln 1 plus x, so it's going to be 1 plus a half over 1 minus a half. Let's sort that out, shall we? A half ln 3 over 2, so is that ln 3? 3 over 2 divided by a half, yeah. So that's 3. And then, if I remember right, yes, they want ln p, so let's get that half up there, shall we? So it's ln root 3, because 3 to the half, obviously the half comes up as a power. Done. F dash of naught, a lot easier. Putting naught in there, we just get minus 1 over 3. F double dash of naught, again, quite easy. Putting in there, we get 2 over 9. So that means that f of x is, and if you can't remember it, like I said, formula's there. It's f of naught, so it's ln root 3 plus, and it'll tell you nicely, x times f dash of naught, so it's x times f dash of naught. Then x squared over 2 factorial, which is 2, times f double dash of 0, 2/9. Tidy it up, so we get ln root 3 minus a third x. And then here we're going to get plus 1/9 x squared. Wonderful. How shall I check that that's right? Oh, where's my mark scheme? Sorry, it won't be a second. Whew. Way down here, let me see. Ln root 3 minus 1/3 x plus 1. Oh, look at that. Full marks, thank you very much. A marks, it's all right, it's not bad. Okay, there we go.